What we're going to do now is look at the JavaScript language and its capabilities. So we're going to see how JavaScript works. We're going to look at the syntax, how we compare it to things that we might already know, and see what it's different. Right, as I said this morning, I can't really hope to tell you teach you to program JavaScript by standing in front of the room and telling you about it. So you need to couple what you learn in these lectures with self-study, reading manual, play around, try it out. It's by far the easiest thing to do. And look at examples. And there are loads of links on the wiki. So I've been populating the JavaScript pages on the wiki with lots of information. Go there and start to look. If you get really stuck, that's when you can find it. So, if you look at JavaScript, you can see that it's made up of three things. So it's drawn a Venn diagram. It's made up of some ideas, some good ideas, and some bad ideas. So, let's break this down. The ideas, well, these are things that are neither good nor bad. They have pros and cons. So, we can look at these. We can see that JavaScript is a loosely typed language. It doesn't have strong typing. This has benefits. Usually it's attributed with faster application development, but equally it can make it easier to introduce bugs. It uses something called prototype or prototypical inheritance. The problem with this is it's a bit different to everything that you've seen before. There are no classes in the language. We'll come to that later. So it doesn't behave like Java, for example. It's also got dynamic objects. So dynamic objects are where you've got an object, you can just change it, you can add new methods to it. This is a good thing if you want to build things quickly. But again, it can introduce bugs. If we look at the good ideas, functions are first-class objects. So you've got lambdas and you've got closures. You can do functional programming in JavaScript. That is really powerful. We'll look at some examples in a bit. It's got another thing called object-literal syntax, otherwise known as JSON. It means it's really, really easy to create objects. You can literally write an object in code. You have to create a class, then create an instance of the object, you can literally write the object. That's quite powerful. However, bad ideas. I kind of alluded to this throughout the morning. There are a number of problems. So, what we've got here. The entire programming system is based around the idea of global variables. It's got a single global namespace. That's bad. Because if you dilute that namespace, you can introduce bugs that are really, really difficult to track down. And when we look at web browsers later on, in a few lectures time, we'll see some examples of how to break it. It's got unusual scoping rules. So it's got a syntax that see like it uses squiggly braces to open and close blocks. In most sane languages, every time you open the block, you open a new scope. Any variables inside that block belong within that block. It's not true of JavaScript. It completely rewrites the rules in scoping. JavaScript's got a lenient parser. That means that badly written JavaScript code will run, or at least the parser will try to run, even if it's not syntactically correct. This might sound like a genius idea for those of you who are pretty sloppy coders, and don't mind missing the semicolon at the end of the line. However, it can introduce really interesting bugs. We'll see those in the next section. It's got loads of unused reserved words. Actually, it's something that is improving with the different JavaScript standards. ECMAScript 6 is coming into play to remove some of the reserved words that were working. But there were lots, certainly in the other versions of the language, there are lots of reserved words. So all of the reserved words we see in Java that you couldn't use in the language, it would be illegal to use in the language. So they didn't actually play any part. They didn't have any function. An example of that is the word class. You couldn't use the word class in your JavaScript code. You couldn't have a variable called class, for example, because it's illegal. It's a reserved word. But it doesn't use a string. It's a bit crazy. Unicode support is broken. That's still the case today. That's true of many languages. And when you come to Python, Python, Unicode support is terrible. And there's only a single numeric type, so there's a number. And that's it. There's no floating point numbers and integers, just a number. And that can cause problems, especially when it comes to efficiency. So if we look at it in a little bit of detail, we see that the language has what's called simple types. So it has a number of base types of them. There are numbers, there are strings, there are booleans. There's two special types, null and undefined. They're special because sometimes they're equal to each other and sometimes they're not. And they have slightly different meanings. And then you've got objects. And the object, there's a standard object, but there's also a function, a type of object, and there's an array, which is a type of object. Objects are nothing more than mutable key collections, i.e. they're things with keys and values. And you can change the keys and you can change the values. Functions and arrays are special kinds of objects, so they can have keys and values too, which leads to some interesting problems potentially. Now you'll see that again in a bit. Numbers, strings, and booleans, they're basically like objects. They behave like objects, but they're not objects. They're not the same type of objects as the other things. In particular, they're immutable. So you can't add a property to a number. You can't add a method to a number. Same goes for strings and booleans. Keywords. Okay, so in JavaScript, whenever you use a variable, you have to declare it. Well, actually, you don't have to declare it. You can let the parser do it for you, but that's a really bad idea. We'll look at that next time. Why is that? But the var keyword is the way that you declare a variable. If you've declared a variable, then you can use the type of keyword to determine the type of that variable. So we've got an example here where we declare the variable A and set its value to 1. So that variable is that's a number. As we can see here, we do type of A, it equals the string and number. Okay. The syntax I've already said it's mostly C-like or Java-like, depending on how you look at it. I think C is the older language. So curly braces define blocks. Comments support both C and C++ styles, so double slashes or slash style, and start slashes, blocks. The branch statements behave like in C and Java. So you can if then, if else, if else, so on and so forth. You can go on and go on. All fairly simple. There's a switch statement. Interestingly, the switch statement is a little bit more powerful than C in Java, because in C in Java, the expression in this switch statement has to be a constant. In JavaScript, it does not. It can be something that can be evaluated. So you can do interesting things with switch statements. Right, looping constructs. For loops, just like in C. So for I equals 0, less than some value, I plus plus, for example. Same is true for while loops and do while loops. Show of hands, how many people in the room have ever used a do while loop? Okay, quite a lot of you. Why?
Just to evaluate the first statement, you need like the first operation has to be done, and then.
Yeah. Did you find that happens very often? Because I know.
It depends.
If I think about all of the code that I've ever written, it's like one or two, and I've written a lot of code. There's got one or two instances. Okay. So it's interesting that so many hands. JavaScript has a thing called for-in loops. These are a little bit like Java for-in loops, but a little bit different at the same time. So you can loop over the properties of an object. So if you've got a beehive object, which presumably contains bees, you can loop over them. But there's a caveat. The caveat that is with inheritance, you get the inherited properties as well. And not only when I'm talking about properties here, I'm talking about all of the methods as well. So you could literally be getting functions as part of your iteration, which is probably not what you wanted if you're looping over the properties of an object. As with C and Java, break exits a loop, so you can have a for loop, you can break it and you can break the loop early, or you can break from a switch statement, or from a case in a switch statement. Break can optionally have a label, like in Java. Show of hands, how many people have ever used a label in Java? Okay, so not that many. Right, how many people knew that you could have a label in Java? Probably the same people. Let me give you an example. Okay, so students. Okay, I don't know how many of you can read that. Terrible, but let's see, we've got two loops. A loop over I and a loop over J nested within each other. Let's say you want it to break out of both loops. So maybe you've got an if statement. If something. You want to break out of that, break out of those two loops in that if statement. Obviously, if you put a break in there, it's a standard break. You'll break out of the inner loop. But what if you want to break out of both loops? Well, that's where the label comes in useful, because you can write a label, put our label out there, and you write it as a word followed by a semicolon, followed by a colon, full colon, and you could say here, break outer, and that will actually exit both loops at once. So that's actually quite a useful construct in some scenarios. And you can do that in Java, and you can do that in JavaScript. Quite a useful thing to know. Okay, what else? Strings. Strings can be defined using double or single quotes, but you can't match them obviously. Start with the same method that you end with. So two strings here be equals b. It'd be true. Concatenating strings. We saw this earlier in the wax video, but you can concatenate strings by adding them together. Backslash is the escape code. So if you want to put a new line in, you can backslash it end, for example, and you can escape quotes and other characters in the same way you would in any normal language. Exceptions. The exception syntax is the same as Java. You've got, one slight caveat, all exceptions in JavaScript are unchecked. So in Java, quite often you have to declare that a method throws an exception. In JavaScript, you never do that. You just throw it anyway. You can throw exceptions from wherever you want in the code, and you never have to tell anybody that you're going to do it. Which can cause problems. So the standard construct, try catch and try catch finally, ported. The throw statement throws an exception, just like it would in Java. However, in Java, you can't just throw anything arbitrarily. It has to be an instance of throwable, which is usually an error or an exception, or one of their subclasses. In JavaScript, you can throw any kind of object. In fact, you can even throw a function if you wanted to. Don't do that. There is a bit of a convention. It's not necessarily widely followed, but there is a convention. You normally, if you're going to throw something, you throw an object that's got a name field and a message field that usually contains the reason that you throw this code. So that's kind of the de facto convention. Objects. So objects are fairly interesting. We've already said that they're mutable collections of keys and values. They have properties, so the keys are properties. You can use block notation to get the property. The property's value can be any type, so it could be a function, in which case that property represents a method on the object. It could just be a value. It could be a number, for example. There are a load of ways of building objects, but there are two common ways. The first one is what's called the new object syntax, where you create a new object using new object, and then you set properties on that object. So basically what you're doing is creating a blank state. You're creating an empty object, and then you're filling it up with properties. So in this case, we've got an object called person, and we set the first name to Joe and the last name to Block. Alternatively, and somewhat more neatly, we can use what's called the object literal syntax, and we can actually just use the pair of squiggly braces on the block and define the object within that block, as is sort of illustrated here. So you can say, well, person equals squiggly brace, first name, and then colon the value, last name, colon the value, and close the whole thing off. I already said that you use dot syntax for getting the value of the property. You can also use square braces, and then the property name in quotes is something as a string. Sometimes you have to use the latter. So you're going to run into instances in the coursework, for example, where you have to use the latter, because the word that's being used as the property name is otherwise illegal in the language. Actually, a good example of this would be using the word class as a property name. So we cannot legally in the language say person.class equals doctor, for example. We're not allowed to do that. The language completely forbids it. But we can say person, square brackets, quote, class equals doctor. And we can retrieve that class property the same way. Okay? So there are certain situations where you have to use the last one. But in general, you'd probably prefer the first one, if you can get away with it. I already kind of alluded to this earlier, but this literal syntax is what you'll often see referred to as JSON, JavaScript Object Notation. And this has become a really big thing recently because it's a really good way of serializing the data within an object and passing it around. It's a great way of transferring data across the web, for example. Okay, arrays. So next type. So arrays are special kinds of objects. They contain numbered items. You can create them two different ways. You can create them with a new array constructor, and inside that you can pass in the things you want to put into your array. Alternatively, you can use the literal syntax, which is much tighter and much nicer, and you just use square braces. You comma separate the things you want to put in your array. To get the values in the array, in this particular case, the keys are numbers. So you use a square bracket syntax, and you pass the number of the index of the item you want to retrieve from the array. So that's fairly simple. You can find out how many items are in an array quite easily by using the length property. And this will be automatically computed based on the number of things. You can, but don't, use non-numeric keys. If you want to use non-numeric keys, just use an object. It's really a better option. Because behind the scenes, they raise really weird things. There is a little catch here. The Python keyword applied to an array gives you objects rather than array.
Is there actually a difference between those two, the way you define them, like true new or just true the var?
In this particular case, you get exactly the same.
Do they use the memory differently maybe or something like that? Memory management is different?
Yeah, so in this case, there wouldn't be a difference, but in certain circumstances, there will be a difference in the way the memory is allocated. Memory management in JavaScript is a bit of a weird thing. We'll, in a few slides' time, we'll come back to that, and maybe I'll try and answer that a bit more. Generally speaking, you should prefer the latter form. Okay, certainly in modern JavaScript, literal notation is kind of the way to go. People don't tend to use new keywords that much.
Same thing with the object around the slide where you create a new object.
Yeah. I mean, you could do it, but why would you do it? When you could, if you want to create an empty object, why not just say A equals a set of curly braces with nothing inside? It's less code to write. It has some benefits that you'll see in a minute. Okay. Right. Functions. Functions are types of objects. However, well, maybe saying the type of a function is a function. Unlike with array. There are three different common ways of defining functions. You can declare them, so you say function name, there's parameters, and then the body of the function. You can use an expression, so you could assign a function to a variable, and then use the variable to refer to it. And you can do the object way. I can't say that I've ever seen this used in real code, but you could do it. So you can actually literally create a new function object, you give it the parameters and you give it the code. And interestingly, you pass the code that's going to be run as the body of that function as a string. Maybe security concerns are doing that. We'll come back to that again in a future lecture. Okay. Because the functions are objects, it means we can pass them around. So JavaScript is a fully functional language, and we can do cool things. So we can use higher order functions, for example. So JavaScript arrays have a higher order function called map on every array. And map takes the function and applies it to every object in that array, and creates a new array with the result of that function. So in this particular case, this bit here, the function x returns x times x. So it's squaring. It's a squaring function. It's squaring numbers. If we apply this function using the map command to an array that contains the numbers 0, 1, and 2, the result would be 0, 1, and 4 in an array. So it would square every element. Really, really useful. Leads to really tight code. Functions, because they're objects, can have properties of their own. So you can quite literally just go and add properties to objects. Add properties to functional objects. You'll sort of see why you want to do that later. That function there is anonymous. It is a lambda function. So if you think back to the second year when you were doing functional programming, learning about lambdas and closures, in this particular this is not a closure, this is a lambda function, but closures are also possible. Okay, objects. So we saw how you create objects using the new object, and you can use a literal statement. You can define a constructor that makes objects. Again, this is kind of old-fashioned JavaScript, so you don't tend to find people doing this so much these days, but it is a useful paradigm to know about. Here's an example. This is a constructor function. The constructor function, first letter begins with an uppercase letter. Now that's the convention. So any function in JavaScript that has an uppercase first letter is something that you should use the new keyword with it. Okay? If you look at what this does, it's a function called cast, capital C. It takes in parameters, name, model, and year. Internally in the body of this constructor, it says this.make equals make, this.model equals model, this.year equals year. What it's doing is setting properties of this function to those values. Okay? So internal properties of this function object are being set to those values. When you use the new keyword, you'll end up with with an object that's got make, model, and year properties. You can use it with nuclear with the flare for constructing a new car. And I've already said that. So, okay. JavaScript does not have any classes, even though even though it does have the class keyword you're not allowed to use. The object-oriented syntax, or the ability to do object-oriented programming, comes purely out of a couple of other language features. And there are kind of two different common ways of doing object-oriented programming in JavaScript. And I'm going to show you both of them. So up to this point, pretty much every object-oriented programming language you see, you've got classes. You make instances of classes are called objects, and you do things with your objects. You can't do that in JavaScript at all. So as I've already said, there are programming methods which let you achieve object-oriented programming in different ways. So, the first one, the prototype pattern. You've already seen how you can use you can create objects by adding empty objects or using constructor functions. You can do a new object and then add the properties to it, or you can create a constructor function that you use a new keyword with. If you do that, you get a best way of describing this. Any constructor function, or actually any function object, has an internal property called prototype within it. So every function that exists in JavaScript has a thing called prototype. So you can do some function object or prototype. The prototype is a kind of internal way that JavaScript uses to manage inheritance, because it lets one object or one function object inherit properties from another function object. And you can inherit fields, you can inherit methods. When you've got an instance of an object, and you say, I don't know, object.a, internally, Java will look for an A property in your object. If it doesn't find it, it'll go to your object prototype, and it'll look for an A object, an A property. If it doesn't find it, it'll go to that object prototype. It'll search the entire prototype chain for that property. And if it doesn't find it, it'll return undefined. But if it does find it, it'll return. This enables you to do some interesting things. So, if we look at a code example, I think that's probably the easiest thing to do. So here we've got a constructor object, or a constructor function that creates animals. So inside this animal constructor, it sets the name to animal, and it declares a method called getName, which returns that name. Okay, this bit of code here should be fairly easy to understand. Now, rather than creating animals, maybe we want to create specialisms. So maybe we want to create cats. We could declare another constructor function, in this case called cat. That in this particular case, we've decided that it's going to take a name in, and it's going to set internally in its constructor. It's going to set the name property to the name passed in, and then we do some code. We set the prototype of the cat to animal. If we then create an instance, we use the constructor function to create a new cat, and we happen to call Henrietta. So var my cat equals new cat and Henrietta. We can then, because of the prototype inheritance, we can call the getName method on our cat. And what will happen is the interpreter will see that the cat type doesn't have a getName method, but its prototype does, and it'll pull it down and it'll run the function and execute it. And in this case, it would return the name of the cat as being Henrietta. So hopefully this example kind of shows that you can use the prototype chain to achieve inheritance. You can make one object depend on another object, essentially. You make it pull bits from another object. The prototypes can be manipulated to add properties to all objects dynamically. You can do crazy things with prototypes. And there's even a JavaScript library called prototype.js, which does crazy things to all the objects. Here's another example then. So in this example, we create a constructor function for a person. We take the name of the parameter, we set the property. We create two people, person 1, person 2, named Bob and Annie respectively. We set person 1's hobbies to canoeing. If we try looking at person 2 and look at their hobbies, we'll see that the result will be undefined. That's logical because we haven't set it. Okay? So setting the property of one object, in this case, doesn't affect the property of the other object. Logical. If we set the prototype, a property of the prototype of the person object, in this case we set scientist, then if we look at person 1 and look at their occupation property, we'll see that it's a scientist. If we look at person 2, we'll see the occupation property, we'll see that it's scientist as well. So the prototype has manipulated both instances essentially. It's added new properties to both instances dynamically. This can be a bad thing because if you, for example, manipulate the prototype of the object class, of the object type, so if you use object.prototype and you change it and you add some new properties, any of those for in-style loops that you might have in your code could potentially break because you're now introducing new properties that will be looped over that maybe you weren't expecting. So it means that one library that you maybe use in your JavaScript code that was written by someone else could actually stop your code from working. This is a little bit of a problem. And generally speaking, manipulating the prototypes in this way is kind of frowned upon these days. If we have to use this approach, then we can use the instance of operator to find the types of things. So let's assume that we create some animals, cats and dogs, and cats and dogs are types of animals. The instance of operator, so if we create a cat, so an object as this is a cat, we can use it to check that it is a cat, and it will also check for an animal. True. The cat, my cat object is an instance of object. True, but it's not an instance of dog. That's all fairly logical. Modern JavaScript kind of, as I already said, sort of frowns upon doing inheritance and objects in that kind of way. The sort of standard way of doing things now is something called differential inheritance. So it's a completely different pattern to doing object-oriented programming. The idea is really conceptually very simple way. You start with an object. So in this case, we define an animal, and we define it using JSON notation. Let's say we want to create another animal, or something that inherits from our animal, in this case a cat, and then we want to customize our cat so it behaves slightly differently to animals in general. The way that we do it is like this. We use a thing called object.create, a method called object.create. And to that you pass an object, and basically it's like a bit like a cookie cutter. It makes stamps out a new object that looks like the same as your previous one. It's a new object, so it's got its own properties and things, but you can add and manipulate it as you want. So we can add a meow method to our cat, for example, that returns the string meow. If we do this, our animal doesn't have a meow method, but our cat does. So our cat gets all of the bits from our animal. We're fine. One slight caveat, although it's less relevant now because I think all of the major browsers are using the latest versions for ECMAScript 5, but Object Create was an ECMAScript 5 edition. So it's probably only been about the last year where it's been commonplace. Okay. Conceptually, this differential inheritance is way simpler than doing things with the new objects and the constructor function. It does have a little bit of a limitation. Well, it has some advantages as well. First of all, there's no need to use the new keyword. There's no need to write constructor functions. It's way more memory efficient. So actually, that comes back to the question earlier. Doing things this way lets the interpreter manage memory much more efficiently. It has a limitation there. If you use instance or keyword, everything's in the sense of an object, and that's it. You haven't got any constructor functions anymore. So you can't test whether anything was a cat with an animal. Or can you? Well, there is a kind of workaround. So there is an object that is prototype of function which will check the prototype chain for a specific object, so you can kind of get around that, but it's not very hard. But the real key here is that the emphasis with this differential inheritance is that the emphasis is on what the object can do rather than what it is. So you don't really care about the type of the object, all you care about is the functionality of that object. Okay. So in summary, for the inheritance bit, if you want to do classical inheritance, sort of ACAA, the kind of thing that you do in Java, but not quite the same because you haven't got classes, then you do it through constructor functions and manipulating the prototype chain, and that enables you to essentially get the equivalent of a sort of class hierarchy. But differential inheritance is much simpler because you don't have constructors, you don't have to use new keyword, you just create objects, and then you make objects build on other objects, and inherit from other objects. And the key thing here is that if you use your cookie cutter approach object or create and stamp out a new object, the sub-object that you create from that is only, in terms of memory usage, is only encoding the differences. That's where you're saying memory. You're not creating all the copies of all the variables again. You're only creating variables that encode that are actually different. So that's why you get memory efficiency. Okay. So, are there any questions? No? Okay, so that was a very quick whistle-stop tour of the basics of JavaScript. Hopefully put in terms of things that you already know, so you can kind of see how the language works. The syntax, as I said, is pretty much what you already know from Java. You can see it's got lots of quirks. That's kind of the subject of the next lecture, quirks in JavaScript. What I've given you, though, is a bit of an abridged version of what JavaScript looks like, because JavaScript in 2016 is a little bit different. The JavaScript landscape is kind of an immense thing. There are lots of libraries, there are lots of different ways of doing things. In fact, if you want to, I don't know, if you want to say capitalize a string, there are got to be at least 100 libraries that will do that for you, and each one will probably do it in a very different way. So JavaScript has become quite convoluted as a language. There is this standardization process in the script, but it moves slowly. So I was told at the end of the last lecture that the latest version of Firefox, I think Firefox 49, now supports ECMAScript 6. Chrome does as well, but I don't think the other browsers do. I'm not convinced that ECMAScript 6 is actually ratified as a complete standard yet either. I think it's still being developed. There's lots of things happening in the JavaScript field. At the same time, any new changes to JavaScript try and make it better. So a lot of these standards just add new features. But any new changes have to be backward compatible. So a lot of the problems in the language that were created at the very beginning still manifest themselves today. As a kind of lightweight homework, I'm recommending you go away and read this blog post. So fortuitously, this arrived on my Facebook feed this morning. It's a fantastic read though. it really gives you an idea of what it's like to be a JavaScript developer in 2016. It'll mention lots of buzzwords, and it'll mention lots of libraries, but it'll really give you a feel for how fast things are moving, how fast how fast some of the developers, especially in Silicon Valley, are moving on the technology and moving from one technology to another. How fast they're leaving something that they were using last year and moving on to something new this year. So yeah, I recommend you read this. What I'll do is, I think I've already put the link on the notes page, but I can send it right in an email after the lecture. But yeah, definitely worth reading. Just to give you a bit of an idea. It's not very long. It's not very long. It's quite amusing. Okay, so that's it for today. I think I've talked for enough. On Thursday morning, we'll talk about some of the problems with the events.
你现在酿也念